الشبكة العالمية للعلماء الجزائريين إيناس هي منظمة غير ربحية تأسست عام 2016 من قبل أكاديميين ومهنيين جزائريين مقيمين في الولايات المتحدة الأمريكية. الهدف من وراء تأسيسها هو رد الجميل للوطن والمساعدة في رفع مستوى التعليم في الجزائر. مهمة إيناس هي ربط الكفاءات الجزائرية في جميع أنحاء العالم مع نظرائهم في الجزائر. من بين أنشطتها نظمت إيناس مؤتمرا مهما عقد خارج العاصمة واشنطن في الولايات المتحدة الأمريكية عام 2019. حدد المشاركون في المؤتمر عدة قطاعات حيوية تحتاجها الجزائر، واتفقوا على العمل في 10 مشاريع تغطي مجالات مختلفة، نذكر منها التعليم والرعاية الصحية والزراعة والسياحة البيئية إلى آخره. والعمل في هذه المشاريع لا زال قائما. تستخدم إيناس أكثر المناهج العلمية تطورا من أجل تسيير ومعالجة هذه المشاريع. البداية المتواضعة لإيناس تضمنت عددا قليلا من الأعضاء، وهي اليوم تضم مئات الجزائريين الأكفاء من جميع أنحاء العالم. هدفهم هو المشاركة في رد الجميل والمساهمة في بناء جزائرنا الجديدة. هذه الثلة من الكفاءات الجزائرية الفخورة بوطنها تجمع بين التنوع والخبرة مع الاستعداد والرغبة في تمهيد الطريق من أجل مستقبل مشرق للجزائر. تستخدم إيناس منصة تقنية جد متطورة تسمح للأعضاء بالتعاون وتبادل الأفكار والخبرات. كمنظمة قائمة، إيناس لديها أقسام عملية مختلفة تضمن الدعم المحترف لجميع أعضائها ومشاريعها وتظاهراتها العلمية. نرحب بكل الكفاءات الجزائرية في العالم للانضمام إلينا في هذه المهمة النبيلة. الجزائر أكبر منا جميعا، فلننهض ولنترك بصمتنا.
The International Network of Algerian Scientists, INAS, is a non-profit organization founded in 2016 by Algerian academics and professionals residing in the USA. The motivation is to pay back the homeland and help elevate the level of education in Algeria. INAS's mission is to network Algerian competencies worldwide with counterparts in Algeria. Among its activities, INAS has organized a significant conference that took place outside of Washington, D.C., USA in 2019. The conferees identified several need areas in Algeria and agreed to work on 10 different projects covering areas ranging from education, healthcare, to agriculture and ecotourism, to name a few. The work is ongoing and progressing. INAS is adopting the most contemporary and proven scientific methods to address these issues. INAS's humble beginnings included a few members. Today, it accounts for hundreds of able Algerians from the world over. Their goal is to participate in the rebuilding process of our new Algeria. These able and proud Algerians combine diversity and expertise with benevolence to set a path for a bright future in Algeria. INAS uses a top technology platform to allow members to collaborate and exchange knowledge. As an organization, INAS has different departments that ensure professional support to all its members, projects, and events. We welcome all Algerian competencies worldwide to join us in our noble mission. Algeria is bigger than all of us. Let's stand up and be counted today.
تتوالى الشهور والسنين على تأسيس منظمة إيناس لتضع اللبنة تلو الأخرى من أجل التشييد والبناء الذي تحملت تكاليفه وأعباءه سواعد نخبتنا العلمية والفكرية، كل على حسب موقعه وتخصصه. تمر 5 سنوات على إنشاء منظمتنا، وهي تزداد من يوم إلى آخر اشتدادا في عود.
So, hello everyone. We are sorry for the technical issue we had. And hello and welcome to everyone's tuning in. I am your co-moderator for today's event, Qamardin Aisu, who is a structural geologist and geomechanicist. Today's webinar, titled The Fundamentals of Fracking and Unconventional Oil Exploration, as part of the project of the new project, Advances in Geoenergy and Renewables. The aim of the project is merely to provide you, young professionals, university students, and the general public with the technical background for the technology that is used in the energy sector. So, without further ado, let me introduce you the leader of the project, Geoscience Project, Dr. Mohammed Al-Rouj. He will introduce you, Dr. Fouad Badrouchi. Please, Dr.
Thank you very much, Qamardin. Thank you very much for the introduction. Assalamu alaikum, everyone. And we apologize for the short technical problem when we started. So today we are very glad to have Dr. Fouad Badrouchi from North Dakota University. Assalamu alaikum, Dr. Fouad. Thank you very much for accepting our invitation and for the exciting lecture.
You are the most welcome.
Shukran. So Dr. Fouad Badrouchi is an assistant professor at the Department of Petroleum Engineering, University of North Dakota since July 2021. He earned both his bachelor and master's degree in petroleum engineering from the Faculty of Oil and Chemistry in Boumerdès University in Algeria. In 2021, he earned his PhD in petroleum engineering from UND after working on building a large-scale slurry loop and studying hull cleaning. He graduated with excellence in dissertation writing award. Dr. Badrouchi was the drilling simulator lab manager and instructor for 3 years at the UND, where he used the lab for training students on drilling and well control operations. Dr. Badrouchi research focuses on, but is not limited to, drilling and completion, production optimization and enhancement, EOR, and hydraulic fracturing in tight and shell formation. And today he is going to share with us fundamentals of fracking in oil and gas industry. Dr. Fouad, please, the floor is yours.
Thank you very much. Shukran jazilan, Mohammed. Thank you very much for this opportunity. And in the way, sururi to present something to my country. And I consider Algeria as my country. I spent there a couple of years. So without any further delay, so just quick background about myself. I got my high school diploma from Tunisia. Then I went to Algeria, where I studied petroleum engineering, Jamiat Boumerdès. And then I came to the US, where I got my petroleum engineering degree, PhD degree. And I started working at the University of North Dakota as an assistant professor. Other than that, I had a couple of other activities with different associations and different organizations. So today's topic is very important topic that is of great importance today, because people are talking a lot and officials are talking a lot and everyone is talking about it, but most of the people who are talking about hydraulic fracturing and conventional resources and shale gas or shale oil, there are people who are not technical people, so they are not from the field. So the message that they are sending to others is missing something very important, because before you judge if something is good, is bad, you accept it, you do not accept it, you need to have an idea on all the surrounding and get an idea about the technical aspect of it, and then you can decide if it is something good or bad. And in today's lecture, it's very objective presentation, يعني موضوعية جدا, بدرجة إنه we will talk about the good thing, the bad thing, and it's up to people يعني to decide what they think about unconventional resources أو الموارد الغير تقليدية and hydraulic fracturing or fracking. This will be our agenda today. So we'll start with a brief introduction, نقدموا الفكرة. Then we'll talk about hydrocarbon generation, تكوين النفط والغاز. Then we'll talk about drilling and well construction, الحفر وبناء الآبار. ثم what is unconventional, ما هي الموارد الغير تقليدية. So when we talk about unconventional. Directional and horizontal drilling, لأن هناك حفر العادي اللي هو العمودي وثم الحفر الأفقي. Then we talk about fundamentals of fracking, أساسيات التصديع المائي. الهيدروليك fracturing we call it more التصديع المائي أو التكسير الهيدروليكي. بعدين نتحدثوا على الإيجابيات والسلبيات بتاع الموارد الغير تقليدية واستغلالها. Then the water concerns, which is the main point that cause a concern for everyone. Then we'll talk about the also the water concerns هي المخاوف تتعلق بالموارد المائية. And the last topic it will be أنا حبيت نسميه بالطريقة هذه Algeria to develop shale gas despite challenges. يعني الجزائر سوف تطور الغاز الصخري رغم كل التحديات ورغم كل شيء، لأنه from the situation that is happening in the world today, not only today, even yesterday and the days before, تحتم على الجزائر to go into يعني this direction of shale gas. And we'll talk in the details in the last section where we have some conclusion and discussion. So starting with the energy. So the world is in need of energy. الطاقة نحن we need it. We need it for electricity, we need it for our industry, we need it for our homes, we need it for our computers, we need it for our grocery. Even what your clothes, they are based on hydrocarbons. Yani we need it for too many reasons. So the energy demand in the world, it is increasing. As you can see, compared to 2001, how the increase that we see of the demand on electricity and the demand on energy. So the world is evolving, and by 2015, you can imagine how much we need more energy. So the world is in need to more energy to develop, to keep surviving. And in the same way, now when we project this to Algeria, also Algeria, you see that, for example, here you can see the electricity consumption, how it is increasing year after year, and you can see after 2015 how it is increasing more and more. At the same time, the total energy consumption, which is the gas consumption, and this is a big problem that's happening to Algeria. Domestic consumption of natural gas is increasing tremendously. So from where to get this electricity? So this electricity, mostly it comes from different sources, either from coal, فحم الحجري, from oil, نفط, from gas, اللي هو الغاز, from الحطب, from the woods, from nuclear power, or from some renewable like wind power, الطاقة الهوائية, الطاقة المائية, الطاقة الشمسية. But they are not that much. So the most proportion in the world that we use it or we rely on it as generator for our energy is what we call them fossil fuels. الوقود الأحفوري، يعني اللي هو الكويل ولا الاويل ولا الغاز. And we'll talk about them, the three of them، يعني نحكوا عليهم بعدين together what they are and how we generate them. So you can see here how the increase, how much the world is depending on these. So here we have the coil, we have the oil, and we have the gas. So you can see how we rely on these considered as 85% of all other sources. So we still have a couple of decades to go. We are relying on coal, oil, and gas, or what we call fossil fuels. Okay, and this is another schematic that shows you how much consumption of petroleum, of coal, and natural gas we have comparing to the other types of energies. Now, I'll take you in a quick trip to the hydrocarbon generation. So how the رحلة بتاعت تكوين النفط والغاز كيفاش. All of you know, you have heard about oil and gas that has been generated approximately more than 300 million years ago. So it's long time ago, when all the organic matter deposited in the bottom of the sea floors or in the woods or everywhere. And then after that, we had some sedimentation. So this organic matter has been preserved. So, you know, with the movement of the ocean or the rivers or any streams, so these organic matter has been covered totally and it was preserved. So تغطت وتحمت من الأكسجين so ما تصيرلهاش الأكسدة. فمع الوقت, when it goes deep and deep, because you are bringing more and more sand and more sediments from the continental shelf that is covering this organic matter, and it's going deep and deep and deep and down. So what's happening when we are going deep? So we have organic matter, we have the temperature will increase with the effect of time and the pressure that is increasing. This will lead to the generation of coal or oil or natural gas. Okay, so the condition of forming each one of them is a little bit different. So coal generally is not very deep, we find them, and they are based on wood type of organic matter اللي يجينا من الشجر ومن الحشيش ومن الانواع هذه من المواد العضويه، مع قليل من الضغط والحراره يتحول الى كويل. الاويل يسحق الاورجانيك ماتر خاصه اللي تاتي من المصادر البحريه، مع كيف مع ال pressure and heat it will generate some oil. The gas will need more heat and pressure. So generally we find it deeper than oil. يعني في مكان أعمق. So the organic matter, you can imagine it is down, and with years 300 مليون سنة, so it is getting deep and deep and deep and deep and deep. So that's why we find it like a couple of kilometers. يعني في الجزائر we are talking 3 kilometers, 4 kilometers down deep. يعني you can imagine. It's like you have all these rocks on this formation. So this is what we call a source rock or الصخرة الأم. السورس روك هي الصخرة or rock that has all the organic matter that we talked about earlier, and it has been buried deep and deep and deep and deep with the heat and with the temperature and pressure that oil will be formed. So if we take a zoom, we will have a source rock that has the organic matter المواد العضوية, and we'll have on top of it another formation, we call it reservoir rock, يعني خزان. Why we call it خزان؟ لأنها it has porosity، يعني عندها نفاذية، at the same time المسامية والنفاذية بتاعهم عالية، يعني permeability and porosity they are high. So it allows the fluid to flow inside, and it can, like sponge, it can have a lot of oil in it. And we have something we call a seal rock. So this is a cover rock that is impermeable, so it will not allow the oil to go up to the surface. So what happens? Usually we have 10 to 20% of hydrocarbons that are generated, yani they migrate from the source rock to the reservoir rock. And you can imagine if 10 to 20% exits this rock, that means the remaining is around 90 to 80% of oil is remaining here. So we are talking about 90% أو 80% من الأويل من النفط بقاء حاصل في الرش في لاغوش ماء والسورس روك. Okay? Donc, when we are talking about unconventional, and we talk about it later, this is the type, for example, a type of oil that we want to get اللي هو قاعد حاصل في الشيل, because usually this rock is a shaly rock. After now we talked about where is the oil. We know it is deep, it's 2 kilometers 3 kilometers deep. So how to get access to it? كيفاش نوصل لهذاك الخزان متاع النفط and get that oil out of it? That's why we have something we call drilling. Drilling is what? Is like drilling a hole in the wall. يعني لما تحكم الشنيال تحب تعمل حفرة في الحيط, what you need force and you need rotation. The same thing we are doing here underground is we need مثقاب اللي هو drilling bit and a way to rotate and weight on it, apply weight, and you start rotating. When you start rotating, you will be forming a hole, حفرة, حتى لين توصل للريزرفوار. But unfortunately, we cannot go this way. يعني any one of you who have been in the beach, who went to the البحر على الشط, when you start digging a hole, right? As soon as you start, after a certain depth, it's gonna collapse. So to prevent the collapse of the formation, we need to do something we call wellbore integrity. So we add some casings. The casing here حديد, جعبة حديد, we put it inside, and it will protect the walls from collapsing. Okay, and then we put cement, so we cement it. And there is another very important reason why we do this. Usually, Lenap aquifer or aquifers, we find them shallow depth, يعني قراب للsurface. And when we are drilling, we are using drilling mud, so fluid forage أو الطفلة بالعربية. This drilling fluid, we don't want it to get mixed with this water. يعني السائل نتاع الحفر ما نحبوش يتخلط لنا مع الماء اللي يجي من الناب aquifer. So what we need to do is we put a casing and we put cement to protect this aquifer here and prevent any contact or contamination to it, because this is drinking water. After we leave it to dry, the cement, once it is dry, we drill another hole, we put a casing, we cement it. Then we do the same thing another time, and we do the same thing. And then once you reach the reservoir, what you need to do is you need to cement it too, and you do some perforations, and you'll allow the oil to come out. Some people, they say how the oil will come out. If this is a permeable formation, like sponge, so the pores are connected, and we'll talk more about this later. So the fluid will come to the wellbore and will be pushed to the surface. Some people, they say, how is that happening? The pressure here is too much, it's very high. We are talking about thousands of psi's of pressure. can reach 5,000 or even more. When we are talking about gas, it's even way more than that. So it's like you have a squeezed bottle, كأنك ضاغط على قرعة كبيرة, and as soon as you open the cap ولا تفتح البوشون بتاعها, the water will come out. The same thing is the reservoir. It is sealed, it is preserved. As soon as you open the reservoir, the oil will come out of it. Okay, but sometimes when this is not permeable, we need to do something we call horizontal drilling. So, or الحفر الأفقي, which we go horizontally like this to have more contact with the formation. Okay, and we'll talk about horizontal drilling in a bit. Okay, now what is unconventional? كنا نحكي على الموارد الغير تقليدية. What's that? Okay, so first, what is the purpose of this presentation when I'm talking about this? First, I want people to be informed, to know what it is, and also for those who are interested to understand the skills that you need to get a job, what type of special skills we need them to develop shale gas in Algeria, and what type of jobs they are in need of, and also to understand the gap, okay, and help advance the science, do the research in universities, what are the directions, especially here in North Dakota, at the University of North Dakota. So we focus on unconventional. So mostly our production is 95% is coming from unconventional here. So it's very important to know, to understand the subject. For those who are studying, they know how to help advancing the science. For those who are requiring or looking for jobs, they know what they need as discipline to get a job in this field. Okay, so in an easy way, بطريقة مبسطة, what is unconventional? Unconventional is any technique that is used to get oil that is different than what we are used to. So بطريقة أخرى, before the 90s, what we know before the 90s is conventional. After the 90s, mostly is unconventional. That doesn't mean all what we do now is unconventional, but the technology that came after the 90s, it changed the oil and gas industry. يعني غيرت كثير في the way that we explore and exploit our resources. So that's what we call unconventional. Drilling horizontal wells instead of going vertical, that's unconventional. Hydraulically fracturing a reservoir is unconventional. Heating the reservoir to get more oil, that's unconventional. So all these techniques are unconventional techniques. So it's an unconventional resources. But mostly now, when we are talking about shale gas, we are talking about the gas or oil that is trapped in the source rock mostly, because source rock is mostly clays and shale. Okay, and the oil is trapped, as we said, 90 to 80%, 80 to 90% of the original oil stayed in it, so it is still inside the source rock, and we want to extract it. And source rocks, they are way bigger than reservoirs. So مثلا في حاسي مسعود, when or any reservoir you take in إغدامس ولا تيميمون ولا it's a basin. We have what we call bassin sédimentaire or حوض, and then في الحوض هذاك we find some reservoirs in it. الرش مار ولا source rock, it covers all the basin. It's very big and wide. That's why it makes the production from it is very promising. The quantities are very high. So then here, this is very important, but I want to take out some of this US report. So the inception of the commercial production of the unconventional plays began in the 1998 after the application of specific procedure, hydraulic fracturing with slick water. So this is at 1998 where people started talking about unconventional production from unconventional plays. And it was developed first in Barnett Shale in Texas by Mitchell Energy in partnership with the US Department of Energy. يعني the US Department of Energy, for those who doesn't know, كأنها كوزارة الطاقة يعني عندهم هنا في أمريكا. It's the Department of Energy that is responsible of all the laws and regulation that regulate the oil and gas industry هنا. And they are always, we call them DOE, so Department of Energy, and they every year they call for proposals, and they encourage universities and companies to innovate and find solution for problems. Okay, so in 1998, the hydraulic fracturing was first implemented in Barnett Shale. Okay, and this is also a very important point. The 1973 oil shock ignited awareness of the end of cheap energy bonanza. In 1973, the United States imported 1.2, okay, uh, gigabillion. So that's the price that they use with a total of 17.7 billion in 1974. And after that, in 1975, it was 35 billion. Okay, so these data are from the Bureau of Statistics. So these numbers, they were worrying numbers for the US. Okay, so they saw that their production, it needs to be boosted. They are consuming a lot of energy. They are paying a lot for energy, and they need to get another source of energy. So in 1976, they approved something they call the unconventional gas research program. And here, this is sad. So هذا شيء محزن when you see these countries يعني in the 1970s 76 يعني they have been thinking of this. They started their studies and their research program to develop the unconventional. And they didn't start it at 1976. So 1976 they launched the program. They started the program for studying unconventional gas and how to exploit it until it came to 2000, and we saw the fruit of these studies recently, 2015, 2010. That's when we really saw the effect of the shale gas, how it improved the US economy. Okay, so this is, for example, US dry natural gas production. This is in trillion cubic feet. As you can see, up to 2010, okay, you can see here we have different uh, tight gas. So when we say tight gas, it's gas coming from low permeability formation. We have coal bed methane. So this is methane that came from origin, a gas from origin from woods. Okay, and you can see that all the gas production, it was coming from these sources. But as soon as 2010, when the exploration and hydraulic fracturing started increasing and unconventional exploration started, you can see that the shale gas dominated, and it's almost 50% of what the United States was producing, or it was almost 100% of what it was producing before 2005, before 2010. So you can see how much, and a lot of you know that before 2010, 2015, the US was a country that has dependency in energy. It was dependent. They were buying a lot of oil and gas from Algeria, from everywhere in the world. But since 2010, they started reducing until there is now they don't import any oil or gas because they made themselves sufficient. They have everything they need for themselves and to export. And that's very important. So when I talked about unconventional, so I talked about permeability and viscosity. So usually these two properties, these are the main properties that affect the classification. So in this figure here on the left, you can see what we call permeability. So when fluids is how the speed of flow through a porous medium, that's defined by the permeability, how fast or how easy it is flowing. At the same time, we have something we call viscosity. The viscosity is the property to the fluid. You see, for example, when you compare different fluids, some they flow easy, some they flow very slow, like oil or water, or when you honey. So they are not the same. The same thing for oil and gas. مثلا oil that is coming from Venezuela, it's similar to this corn syrup that you see here. Exactly, it's like honey. It's very thick, very viscous. The one that is coming from Algeria is very light oil. It's not very viscous, and it's good quality oil. And another thing is we said the permeability. So based on the permeability and viscosity of the fluid and permeability of the formation, you can classify your reservoir as conventional or non-conventional. So the conventional, usually they have good permeability, so the flow is easy, and the viscosity is low, so it's not very high, similar to water or a little bit higher than water, but not too much. When the viscosity become higher and the permeability become lower, now we are talking about unconventional. When we are talking about Venezuela, for example, we are talking about this region here. When we are talking about unconventional in Algeria, we are talking about this region. The viscosity is not very high because mostly it's either gas or some sweet oil, and they have low permeability. So we are in this region in Algeria. Okay, so this is just to give you an idea about unconventionals. So when we are talking about unconventional comparison to conventional, التقليدي مقارنة بالغير تقليدي. So when we are talking about unconventional or conventional, it is local scale. So we are talking about a couple of kilometers, like reservoir. But when we are talking about unconventional, we are talking about the regional scale. As I said, the basin is very big, but the reservoir, they are small. So the source rock is big, so it's covering wide regions. Also, the permeability is very high for conventional type of formations, but it is low for unconventional type of reservoirs. The productivity also is important, كمية الإنتاج. So if you are in a conventional well, so it is producing at thousands of barrel of oil equivalent per day. However, unconventional, they are very low type of production because the permeability is low, so the flow is not that high. So you are talking about less productivity, okay? And also, uh, we need, when you are doing conventional, you don't need too many wells. لا تحتاج يعني بزاف أبيار. You need a couple of them and you are producing at very high rate. However, if you are in unconventional, you need to drill a lot of wells, and we will see this. It's very important. And also, you need to do hydraulic fracturing to these wells. So it comes with a cost, okay? And the recovery factor, so how much you can, we have something proven reserves, and we have what is original reserves that we can extract, and we have some reserves that we cannot get out from the reservoir. When we are talking about conventional, if you have a reservoir that is conventional, the maximum recovery you can get is 40% of that quantity. If you have, let's say, 100 barrels, you only can get 60 barrels of that. But the remaining, or you can get only 40 barrels of that, but the remaining 60 you cannot get them. However, كنا نحكي على conventional, we have problems. So recovery is not high, so you cannot recover more than 7% or 10% of that. Okay. So these are some examples of some unconventional reservoirs we have here in the US. هذا الباكن. So the Bakken is here in North Dakota. وين نحن موجودين. And so what you see here in brown, these are the shale. So the Bakken, we have lower Bakken and upper Bakken, and these are shale reservoirs. And we have here another one, which is the middle Bakken. As you can see, it's not unconventional. However, sorry, it's not the shale, but that's from where we are producing. But it's very important to note that this is considered as unconventional because the permeability is very, very low. So this is a tight oil reservoir. So we need to hydraulic fracture these wells to get the oil out of them. This is the Duvernay Devonian. So also they are getting from the shale. Haynesville Jurassic also they are getting from their production from the shale. This is the Eagle Ford, is well-known unconventional shale play in the US. Also, Marcellus is one of the biggest ones too, and the Barnett Shale that we said where the first hydraulic fracture happened. As you can see, it's big chunk of shale reservoir that they are producing from. Okay, so, and you can compare these different reservoirs. The same thing in Algeria that we talk about the reservoirs and conventional reservoirs in Algeria. Now we'll talk about directional drilling. So this is the operation. So now we are going horizontally to the well, to the reservoir. So we don't go to this. So imagine if you go vertical, so you will be only producing from this region here, as you can see it. Okay, and we don't want that to happen. So we want to produce from the maximum region. Okay, so that's why we go horizontally. Now, if we see the reservoir, so we talked about what is the composition. So reservoir is a rock that is composed of some grains, solids, and in the other hand, we have some fluid inside. Okay. So now we have solid part and fluid part. What we want is to extract that oil. If there is no much connection, you see here, so these are the pores. If these pores are not connected, that means this water or this oil or whatever is stuck here. Okay, so it will be stuck. So what I need to do, I need to fracture this formation and get this oil out from my rock. Okay, so we saw earlier the notion of what we talked about, permeability and viscosity is very important to know. And then we go to hydraulic fracturing. So now we know the reservoir, we go horizontal, we know there is a formation, we know that the oil is stuck, يعني النفط محصور في السورس rock or for that in that tight rock, and we want to get it out of it. Okay, so before we talk about hydrofracturing, I want to talk about some numbers. Okay, so people, they know the scale of hydrofracturing. So in the US, we have 1 million wells that are hydraulically fractured, and you can imagine. So if someone guess how many in the world, we have 2 million wells that are hydraulically, or less than 2 million hydraulically fractured wells in the world. So the United States by itself, it is considered, or it has 60% of the hydraulically fractured wells in the world, 1 million wells. And that's a huge number. Okay, so you can see how the United States is relying on hydraulic fracturing, and this is an image that shows you different reservoirs in the US, and how where, and the dots in red, these are hydraulically fractured wells. Okay, as you can see here, so these are shale gas and oil wells. So this is North Dakota, this is the Bakken, it's here. So this is the Bakken formation. The Barnett is in Texas here. And all these red dots are hydraulically fractured wells. So what is hydraulic fracturing? As we said, the formation, it has some pores inside. Okay, so this is the porosity. This is are the openings that that we have inside the rock. And when we are talking about impermeable formation or shale formation, we have some porosity, so the oil is inside, but there is no connection, so we cannot get that oil out. And it's like we are in this region. As you can see, this region here, it doesn't have any connection. The connection can be between the pores or can be between these channels. Okay, these fractures, we call them natural fractures, or these channels here. So what we need to do is we need to fracture it. So we need to fracture the formation to create that contact between the different fluids, or the pores, so the fluid can flow inside the formation. And that's what is hydraulic fracturing. So the hydraulic fracturing, it has three main components. The first thing is the water. The water constitute 98% of the hydraulic fracturing fluid. يعني الماء اللي نستعملوه في التصديع المائي او التكسير الهيدروليكي يمثل 98% من اجمالي الفلويد او المائع. Now, if how much is this amount? We are talking about from 10 to 20 million gallons. And when we say 10 million gallons, we are talking about 16 Olympic swimming pools. يعني 16 مسبح يعني أولمبي معمرين. هذاك هو الفلويد على الأقل اللي نحتاجوه في الهيدروليك فراكشرنج الواحد البير واحد. Okay? And then we have some chemicals. So because you cannot just frack with water. Someone can tell me why they don't just frack with water. We need to add some chemicals first to change the properties of the water. You remember we talked about viscosity. So the water, when we add some polymer to it, it will change. It will become like a gel. And when the water viscosity will increase, that will help with fracturing. So it's not the same you are fracturing with water when you are making an opening in the rock, or when you are injecting viscous fluid that will help in the fracturing operation. Also, a very important thing that we add some biocides. So libiosid. Why we add them? These are antibacterial additives. And we add them because we don't want any bacteria to get into the reservoir. As you remember, when we talked about the generation of oil and gas, we said the organic matter or المواد العضوية, it needs to be preserved. لازم نحفظها، تكون محفوظة من وقت من الأكسجين، من الأكسدة، ما تصيرش أكسدة. البايوسيد وش يديروا؟ They kill the bacteria. So they don't allow any bacteria to grow inside the reservoir, and it can lead to catastrophe inside the reservoir, deposition, plugging, and too many other problems, and H2S formation, and يخرج لنا الغاز اخرين اللي ما نحبوهمش، حاجات ما نحبوهاش تكون في الريزرفوار. So we add libiosid. The amount of these additives is only 2 to 3% of the total water. And the amount بتاع البيوسيد, you can see it here. So it's 0.1 percent of the 2%. So from the total fluid, it's 0.0001%. But that small amount still is, that's the main thing that was causing the problem among people and environment activists they are who are against hydraulic fracturing. And we'll talk more about this later on how we are treating this. Then the other additive is the propants or the sand. So when you fracture the formation, as soon as you release the pressure or you do the backflow, because we talked about 10 million gallons that you inject, that water you won't leave it inside the reservoir. You want to flow it back, so you want to get it back. الماء اللي تنجكتيه باش تعمل به الهيدريك fracturing لازمك تخرجه من بعد. So you flow it back. When you flow it back, that means the pressure will decrease and the fracture will close again. So we want that fracture to be open. So what we do is we put these propants inside and they will prevent the fracture from closing. Okay, so these are the main three additives we have or the main three components of a hydraulic fracturing fluid. Okay, now let's see the operation, how it is working. So bring our tracks, we do our horizontal drilling, and then after that, I bring my water, chemicals, and propants, and I inject my fluid. So as you can see on the bottom right, this is the operation, how it looks like. So we inject the water, we have those perforations, and we inject, we create the fractures, and then we flow back our water that we injected, we bring it back, okay? And then we create our fractures. So this is the hydraulic summary of the hydraulic fracturing operation. So here you can see the propants. So the propants, they will stay inside the fracture network and will prevent it from closing. So that's what we want to do. First, we fracture. Here we fracture our formation. This is the fracture, how they look like. And then we don't want them to close, so we inject some propants and some sand to keep them open. Okay, and they are very small, like very fine type of particles. Okay, I don't want to go into deep theory of hydraulic fracturing, but why I had this slide. Okay, so I was thinking of putting this slide or not, because I don't want to go into the details of hydraulic fracturing and the technical part of it and the theoretical part of it. But what I want to say to people that today we know hydraulic fracturing. We dominate hydraulic fracturing, not that much, not at 100%, but we understand it. We were able to create models, numerical models, analytical models, numerical simulations. We know how the fracture will propagate. We can predict how what is the shape of the fracture, what is the width, what is the length, at what extent it will go. And this is very important. So today is before I start the operation, I know at 90% what's going to happen downhole, even if it is 4 kilometers down. So we are talking about 4 kilometers down and 10 kilometers long horizontal section. So we know it. And just another comment that I want to tell people, and a lot of people, they don't believe me when I tell them this, because I didn't believe it when they first told me that. So how long it takes them here in the United States, especially in the backend, to drill a well. So before you answer this question, I will answer the question if I ask it to in Algeria, how long it takes. It takes months, sometimes 1, 2, or more. Okay, so this is a huge number. Here in the US, it takes us 5 to 10 days to finish a well that is 4 kilometers down, 10 kilometers of horizontal section. In only 7 days to 10 days, we are done with that well. You cannot believe it at the beginning if you don't go and see it on site. It's insane. But that's how the technology evolved and how the scientific research was integrated to the industry, and they came up with techniques they improved their technology and their drilling and hydrofracturing technology. So that's what I want to say. When you dominate the technology and the science, the operation will be easier and easier. And this is very important for the case of unconventional. So if you ask me from my side, are you with or against unconventional exploration in Tunisia or Algeria? It can't be an easy answer. I say, yes, I am with, or no, I am against. It's not that easy. There are too many things that we need to answer them. So do we dominate? Do we know the technology? Do we know do we have people that they are capable, or are we gonna rely on people that we bring them from outside? So these are the core questions that we need to answer. So how are we gonna proceed? That we know that the world today, we have enough technology. Okay. So we'll keep talking about that later. So this is just to tell this slide that we know how hydraulic fracture is behaving. And also there is another thing we called, and I want to thank the people that I got some also slides from them. Uh, so this is something we called microseismicity. Okay, so microseismicity is what? While you are hydraulically fracturing a reservoir, I am recording what is happening. So وقت you are doing التكسير or تصديع بتاع الريزرفوار, when the rock is opening, it will send some signals, like seismic signal. Like when I do this, when I clap, I'm clapping, so you are hearing the voice. So that's a wave that you receive. The same thing when I am fracturing the reservoir, it creates a wave, an acoustic wave, that I can detect it from the surface or from another well. So imagine here, I am fracturing this region, and I have a sensor that is reading. So as you can see here, this is the part where I am reading what's happening here. By interpreting these signals, I can tell you what is the shape of this fracture, where it is going, what length, what everything. So the technology, we have it now, and the science is advancing. Okay. So let's go now to what are the positive sides and the negative sides of unconventional. إيجابيات وسلبيات. So I'll start with always with the pros and what is good, what is beneficial. In this graph here, it's worth to mention. So you can see, you said from especially 2010, where the revolution of unconventional started. And you can see here the consumption and production, the imports and exports. The most important thing, look at this green plot. What's showing? The curve here. You see, since this date, the imports of energy has decreased a lot. At the same time, what you see about the exports, it is increasing. So the US made its independence in energy. Okay, and this is very important, and that's thanks to what? Thanks to the unconventional revolution in the US. Okay, so what did that create? So it increase in US production. So a lot of wealth, lot of work. The United States had an energy independency of 65% in 2019. Also, it has lower energy price because substitute gas for coal to produce electricity. In the past, they used a lot of coal, الفحم الحجري here in the US, like China, and now they are replacing that by gas. When you, the good thing to know when you are comparing gas to coal, so the emissions, the CO2 emissions of coal, they are 50% more than what CO2 is emitting as CO2. So if you burn CO2 and you burn coal, if this will give you this amount, the CO2 will give you only 50% of that. So it's less pollution, and the US had 12% less greenhouse gas emissions. So the emissions of the US reduced 12% since 2005, and that's a huge number. Okay, and also they use the gas for producing methanol and producing plastics and producing different types of materials. Okay, the other thing is the job numbers. Okay, so in 2010, the unconventional revolution led to almost 600K, which is half a million of people they got employed in direct or indirect way related to unconventional. And they are thinking by 2025, it will impact 3.9 jobs in the US. And you can imagine these are huge numbers. These can solve a lot of problems. Okay. And higher incomes in oil and gas and in all, because a lot of wealth that will come to the country. So the level of life will increase. Okay, so more revenues, and the research and science advance. So in the US, you can see here, so this is the same plot. Okay, this one and this one, they are the same, just this is logarithmic. When we do logarithmic scale, just to emphasize and to see more the change. So you can see here the research in the US, how it is evolving. Okay, And you can see the peak that happened also at 2010, the research, how it went very, very high. So you will have a revolution in too many different aspects that you need to be also ready for that. Okay. Now, when we talk about the cons or salbiyat and the negative sides, so I won't, as I said, I won't tell you everything is good. There are some things they are bad, they are negative, but it's worth to mention that these are old things that happened in the past. That doesn't mean today they can happen again, and doesn't mean they cannot happen too. So I want to show you what people who fear unconventional exploration, what's their fear and what it comes from. So as we said, you remember we said when we have aquifers, we have casing and we have cement. So sometimes when there is a leak here, so the water that is coming from hydraulic fracturing can go to the aquifer and can contaminate this water. And this water is the drinking water that goes to everyone's house. And once it is contaminated with chemicals, with radioactive components that come from the reservoir, it can contaminate the whole region. And that can be true in the case, but that was at the early stages when we didn't really know much about wellbore integrity and operation sites. The other thing is man-made earthquakes, and this is something, sadly, it's reality that we see it here in the U.S. and in Texas. It's a big problem that people they are working on, which is earthquakes. Hydraulic fracturing led to a lot of earthquakes because of too many reasons. Not only because of the injection of fluid underground, but because of the storing. You remember that water that we talked about that you use for hydraulic fracturing, those 10 million gallons per well. After you are done with them, you can reuse them, but when you are done, you cannot clean them at all. So what we do is we inject them downhole somewhere. So you find a good reservoir downhole that there is nothing. You inject that water and you store it for the end of its life. So those injections, those big injections, led to some earthquakes. Okay, and that caused problem in Texas, as I said, and we are working on that. And I'll tell you some alternatives. And there is current research here that we are doing in North Dakota that some of our PhD students, and by the way, he is Algerian, and he's working on other techniques that you can do something similar to hydraulic fracturing, but without using water or using um, what we say water and pressure and the conventional hydrofracturing technique. Okay, I'll talk about that later. Another thing here is very important. So you remember we said there is something we call flowback. So when you do the hydrofracturing, those 10 million barrels, gallons, you need to produce them back. When you are producing that water back, the gas can leak, and it always leaks. And methane is a greenhouse. Okay, so it gas يسبب الانحباس الحراري. لكن what is good about الميثان على خلاف CO2 انه صار له degradation مع الوقت، ما يبقاش على طول في الانفايرمنت. Okay, so these are the main three مخاوف we have from unconventional. Okay, so now is it safe? Now we saw those problems. Is it really big problems? So the most important thing now, you see this casing that we put here and the cement that we put. So today we know that this can be a source of leak, so we protect it. And don't think that this is the only casing. We'll have a couple of other casings too here. So this part is very safe. Okay, so we know that we need to protect this. So we are doing everything to make this zone protected. And also it's very far from the reservoir. Some people, they think that the hydraulic fracture, when it is propagating, like for example like this, they think it's going to reach this aquifer. So that's not the case. That's not going to happen, because usually the aquifer is at this depth and the reservoir at this depth. In some places in Algeria, this can be, I can understand if you see here in the map, so in different regions, uh, when you have the Albion aquifer, Nanab Albion, the depth is between 800 to 1000. and the reservoirs below it are at 3,000. We are talking 2,500. So we have 1,000 meter or 2,000 meter difference. Yes, it's not that too much difference, but it's very unlikely to have this leak to come, the fracture to reach here. So it's not going to happen. What can happen is the leak that happens along the wellbore. Okay, so along the wellbore and comes to the aquifer. But this is 0.00001% chance to happen at today's technology. With what we have, with all the technology we have, the controlling technology, it's not going to happen. And someone tell me if it is even 0.0001%, so we shouldn't take the risk. But sometimes the life is about taking some risks and improving. And you cannot improve your shale gas without doing some mistakes. I know sometimes mistakes they can come with a cost, but that's the only way you can learn in everywhere. That's how the US today, they are drilling one well and hydraulic fracture it in a couple of days because they allow themselves to do some mistakes and learn and learn and learn and advance the research at universities. So they now dominate the field. Okay, so a very important study that came from the Environmental Protection Agency, what you call EPA, المنظمة نتاع الأجانس تاع حماية الطبيعة أو المحيط. So they did a 5 years study, and this was recently published. Okay, and they said they concluded that hydraulic fracturing has not led to widespread or systematic impacts on drinking water resources. Okay, so يعني الهيدريك فراكشرنج ما عملتش اي تاثير كبير على الواتر اللي نشربوا فيها في امريكا. And they say thanks to what? To the safety and effectiveness of state and federal regulation and current industry practices. Why I highlighted this in red? Because this is the most important conclusion that I think. The most important conclusion is not that hydraulic fracturing is not a problem to our drinking water. The most important conclusion is this. Do we have this in our country? If we have it, that's good. So we are safe because the regulation that the United States and the Department of Energy they put for the exploration of unconventional, they are very strict and very tough to follow. And you can يعني بلغة أخرى يعني فما قوانين وفما اطر وفما مسالك نتاع الدوله اللي لازم تتبعها that you cannot misfollow. You have to follow that. If you misfollow it, you'll be in big trouble in the US. So the regulations are there. In our country, do we have these regulations and do we have the agencies معناتها شكون يطبق في هالقوانين؟ انا بدي لانه في دولنا بعض القوانين موجوده او كل القوانين ساعات موجوده عندنا قوانين اكثر من دول اخرى، لكن مدى تطبيق القوانين هذه هل انها تطبق بالطريقه اللازمه او لا؟ This is very important because I will not risk also the country just because I want to get some more income to the country. So before I start any unconventional era or فتره نتاع زي ندخلوا في مستقبل جديد نتاع unconventional, we need to be ready for that with regulation, with agencies, with everything. So I think that that's very important. And also they say and current industry practice, because the industry practice that has been practicing unconventional for a couple of years, they developed their knowledge, their technologies, their techniques, and now they dominate the field. Okay, now let's talk about the المخاوف اللي تتعلق بالموارد المائية. As you all know, so في 2015 تقريبا صارت الاحتجاجات اللي في عين صالح. So and mainly these demonstrations or these manifestations that happened in Ain Salah, it was because people they have some fears related to water, right? And that was the main reservation when the first exploration well was drilled at that region. So people, they said we are against unconventional because we have problems with water. So they related everything to the water. Now, when we talk about the water, okay, at the global level, concern over water use, treatment, and pollution in hydraulic fracturing operation is not new. So this happened in everywhere, not only Algeria. But it's very important, okay? Algeria is considered as an arid country. So دولة جافة تعاني من الجفاف في الجزائر. Okay, it's not considered لأن water stress factor is very high in Algeria. Okay, and According to the World Resource Institute, WRI, Aqueduct Water Risk Atlas, the country's baseline water stress level is arid and low water use. And with more than 95% of the Algeria shale plays lying in the Algerian desert, fully 96% of their area is arid, featuring extremely low level of available surface water. So ملخصه هذا انه الجزائر ما عندهاش بزاف ماء، خاصة في الصحراء اللي هي ما فيهاش بزاف. We know we have the Albion, but that doesn't mean يعني انه we don't have water to do hydrofracturing. So that's why instead of saying, oh no, we don't have too much water, we are an arid country, we need to stop unconventional, we don't do hydrofracturing, that's the wrong thing. We need to start unconventional, understand it, and finance the research to find good ways for water treatment. Find some ways. You need to fund this research. You need to work close with universities and solve it instead of hiding when you see the problem. يعني ما تشوفش المشكل ده نتخبوا منه, we leave it so we don't have it. No, face your problem and try to solve it. Come to a solution. So you cannot, especially as an oil producing country, يعني كل العالم he is producing from unconventional, and you are just fearing from starting that just because of the hydrofracturing. So there should be a plan from the country and from the government, from everyone, on how to develop that technology safely. In the US, you can see the amount of water that is used for mining is only 2%. It's not that much. And you can use that water for other wells, for hydrofracturing other wells. Also, something that we know is for 1 barrel of oil. So if this is 1 barrel of oil that I am producing from this reservoir, I am producing with it 10 barrels of water. So because when you produce the oil, it doesn't come by itself, it comes with water. So for each barrel, especially in Algeria too, we are producing a lot of water with it. So that water also, it is contaminated, it's not good water, and it's very hard to clean it. Sometimes we use that water, we mix it with hydraulic fracturing fluid, and we inject it, and we do the hydraulic fracturing with that water, because that water is produced anyway. So we use for hydraulic fracturing. So you rationalize the use of your water. The good thing here in the US compared to Algeria, so as you can see, this is the stress score of water. The stress score is the water withdrawal divided by the water that is, how to say that, the water reserve. So what you have and what you withdraw, like you use it for hydrofracture or whatever. So the US is not a country that is suffering from an arid climate or anything. So they have some water. And in this map here, you can see the use of water by hydraulic fracturing. And you see how much water it is being used. And this region of the US has some problems with the water reserves, okay? So the US doesn't have that problem of water use, but they are always working on optimizing the use of water. Here you can see the stress forecast for 2040, and this is Algeria. And unfortunately, Algeria is extremely high stress water stress factor, so it will suffer more. One of the top countries that will suffer from arid type of climate. But recently, it was I think 1 year ago, 2 years ago, NASA they showed this map, so they published it, and it was a 14 years study from satellites, and it's 14 years. Okay, so this is very important. And they don't classify Algeria as an arid country, neither as a country that will suffer from aridity in the near future. So we don't know if it's really a big problem, the water, or not, but we need to take it into consideration. This takes me to the last part of my presentation. So these are the main countries that they have unconventionals, and you can see here Algeria, and you can see the amounts of unconventional you have, and you can even compare it to the US. So you see the US, how much shale gas they have, 17.6 trillion cubic meter. Algeria has 20. They have even more than the United States. These are recoverable, okay? So it's a huge amount. And in tight oil, they have 6 billion, and the US they have around 78 billion. That's the main unconventional production you have here. So the potential that Algeria has is enormous, okay? So the US shale gas revolution serves as a unique case study that demonstrates how suppliers can use technology innovation to drive to more affordable and secure supplies of natural gas. And you can see how the United States, when they started their unconventional production, they created their sufficiency and their independency of energy. This is the exports of Algeria. So Algeria, in 2015, they have been exporting 55 billion cubic meter to Europe, comparing to 54 billions in 2016. So it is the demand of Europe is increasing. And here you can see the domestic use, or this is, for example, the oil production, it's declining, as you can see it here. Also, the same thing, the gas production is stable. You can see that this curve here in the back, the green. So this is the production used domestically. So you can see the domestic use of oil and gas is increasing in Algeria. At the same time, the exports and production is constant. So you are having problems. So you cannot supply your clients with enough gas. So you need to find some, Algeria really needs to find some alternatives for this. And this is a study from IA again, and this is sad, to be honest. So when I was preparing for this presentation, something that I felt sad for, that most of the resources that I found for Algeria, they came from study centers here from the US and from other countries, or reports from Total or from this. So these people, they are doing the research, even this basic research, they are doing it for us. And that's an alarming thing. So not our people who are working on this, it's their studies and it's their consulting companies, they are doing this type of work. It should be us who are doing this, not I find these in the website of the United States, So this is just a side comment, okay? And here, as we said, so you can see the production of gas is decreasing. At the same time, the oil is decreasing. So these are the main shale basins we have in Algeria. So this is Ghadames basin. Here we have Elizi, right? Or if I'm wrong, maybe someone can correct me later. We have Timimoun here. We have Ahnat here. Ain Salah is somewhere here. And we have Regan and Tindouf. And this is Midour, or I forgot the name of this basin. So these are the main big basins in Algeria that they have a huge potential of shale oil and gas that Algeria needs to think of exploring. So in May 2014, prior to the demonstration in Ain Salah, the Algerian Council of Ministers, Majlis al-Wazara, gave the formal approval for foreign partners to join Sonatrach in the exploration and development of shale gas resources. First, it was Repsol, Shell, Statoil, and Dragon Oil, and then they gave it also to Total to work on something, and they stopped in 2015. They stopped the work. What is worth to mention? So the proved crude oil reserves in Algeria, so they are totaled to 12.2 billion in 2014. The U.S. Geology Survey, USGS, so you see, this is the source of the data. This is what I'm talking about. So it's close to 6 billion barrels of recoverable shale reservoir. You can see we have 50% of what you have. You can get it another 50% just from shale. Okay, and the same thing for gas. What you have is 159 trillion, and what you can get from the shale is 700 trillion. Is like 6 times or 5 times more than what you have as conventional. So this has a great potential. So here it has been reported that ExxonMobil is negotiating an agreement to develop shale gas field in the Ahnat Basin, southern Algeria. Here you can see it. The horizontal drilling and fracking, and they will do the hydraulic fracturing and horizontal well. So the shale gas zone are probably the Frasnian and Silurian formations, which Sonatrach they tested in 2015. So I saw in Reuters they had this in 2019. So they reported that ExxonMobil has temporarily suspended the above referenced negotiation due to the anti-government protests that emerged in 2019. So when there were social unrest and there were manifestations in Algeria, ExxonMobil, they saw that the country is not stable enough, and they stopped the deal and they don't want to do it anymore. Okay, so the social also unrest can lead to your investors to have the fear, and they don't want to invest in the country when they don't know what's going to happen tomorrow. Okay, so that's also very important. Okay, so this is some comparison between those shales in the US that I talked about and some shales, and someone who knows and someone from the field, he can tell that these properties, they are really, really promising properties. And we have some shale plays that they have more potential than the ones that we have here in the US. Okay, and these are the main shale plays in Algeria with some numbers for someone who want to take a look at them: Gdames, Ahnet, Moidir, Regan, Tindouf, Timimoun. These are the properties, and Algerian shale plays, they lay in this region of good quality type of unconventional plays. They have good permeability, good porosity, good pressure, and so they are good and conventional for the production. So the last thing as a conclusion is I don't want to make it long, so I want to make it a discussion. I will answer your questions, but so if Algeria want to increase, because we need to talk about what's going on in the world today, what's happening in Ukraine, and Europe, they are asking Algeria to increase the exports. Can Algeria increase the exports? So I'm not going to talk about it politically as alliance and the interest of the countries and how they do it. But now, if we talk purely technical, can Algeria give more gas? The answer short is no, they can't. Why? Because the domestic consumption is very high in Algeria, and we saw it. And they cannot, there is no way in this short term to increase the production of gas. So something very important about gas, people they don't know. Gas is not cannot be stored. We don't store gas. Gas is always produced and we need to sell it. Otherwise, we leave it underground. So we don't produce it and keep it like oil, unfortunately. So whatever Algeria is producing is exporting. So if Algeria want to increase the exports to outside, what they need to do, they need to decrease the domestic consumption. That's easy as that. But is it easy to do it? It's not. Also, those who are involved in unconventional, something that is alarming, that it looks like they were not ready in 2014 when the Majlis al-Wazara he agreed on the unconventional exploration. They didn't see the protests and manifestation to happen in 2015. And how can they not predict that to happen? Because they didn't educate the people and they didn't prepare the people for that. Because when you want to start a new era, new thing, new path for energy, you need to prepare the locals. You need to prepare the people who live there and give them the necessary information, and you predict what's going to happen and how to deal with that. And that's what happened in 2015. It stopped, and now no company want to do the experience again. No, like ExxonMobil, they exit, and they don't want to do the same experience that the other companies had in 2015. Okay, so the other thing which is sad, so we are talking about oil, gas, oil, gas. Algeria needs to diversify its exports. You cannot rely 95% on oil and gas. That's not the right thing. So if that's why at the early beginning I told you the answer to unconventional exploration. If someone will tell me, are you with or against, أنت معاه ولا ضد unconventional? I cannot say yes or no. It's a big question. I'm not. So if someone tell me, environment speaking, are you against or for? I am for the exploration. I don't have any fear about the environment. I know that we know the technology. So نحن لا نشكل الconventional لا يشكل خطر على الطبيعة. لكن now talking about using this, because this unconventional is not only for us, it's for other generations that they are coming. So we need to rationalize our use, and at the same time, are we using this money or this wealth that will come from unconventional to build infrastructure or anything? Then yes, we need to do that. So the country needs to come with a plan and discuss it with the people so they know what it will be the outcome. When the United States they start unconventional, how they calm down the people who were against. They told them, okay, listen, We start unconventional, and this is what we promise you to have. This is what we are promising to happen in terms of jobs, in terms of advance, in terms of everything. So people, they understood what that money will bring to the country. Okay, so I don't want to delay on that. Also, Algerian shale gas will not be, as we said, a short-term fix for the European Union in its request or quest for alternative supply. Now they are looking for another supply of gas, and they have been always looking for another supply. Not this is not new. This is not because of Ukraine. This recent what's happening that they are looking for new source for gas. They have been looking for gas for a long time ago, and they couldn't find any supplier that can supply the gas that is coming from Russia. Okay, so here, this is BP report. They say after peaking at over 2 million barrels per day in 2007, Algeria's oil production was at 1.5 million barrels per day. So from 2007 to 2018, Algeria lost zero point 0.5 million barrels per day. And the oil problems of late stem for a long list of factors. So what caused this problem is the aging fields. And this is something that I want to always tell, and I always tell that one of the things is during the colonization of Algeria, the Total and the French, they have been producing from the 7-inch casing in Algeria. And this is something really bad that happened in Algeria. This caused big problem in Algeria that till now the reservoir are still suffering from that production, that massive production. You can never produce from a 7-inch or from a big tubing. That was what France was doing because they want to get the maximum of oil in a short term. And because of that, they reduced the quality of our reservoir, they reduced their age and everything. Okay, and also the low price that happened for the last couple years. Now the price is going up. It's at 110 today. But before the problem that happened in Ukraine, you remember the oil price went to $20, which is very, very low. So that caused all that production to reduce. Okay. Also, when the production is decreasing from Algeria, that's a good thing for the United States because the United States want to replace what Algeria is giving to the world. So the exports of Algeria to Europe from gas or oil or whatever, the United States want to replace that. The only reason what is preventing the United States from doing that is it needs 10 more times farther from Algeria. So if this is the distance that Algeria need to use to send the gas to Europe, this is the distance that the United States need. So that's the only thing. But if Algeria will keep decreasing its exports, definitely the market will be stolen from it and it will be taken from other countries. Okay, this is just a couple of slides that I want to talk about what's happening in Ukraine and the demand of the European Union to get the gas from Algeria. So بخصوص and I'll speak this one. I'll talk in Arabic for this last slide. So بخصوص ما يثار في متى في الإعلام وفي الواحد عن إمكانية أن الجزائر تعوض الغاز الروسي من في أوروبا، يعني هذا بالنسبة يسمى كأحلام، أضغاث أحلام وكلام، يعني كلام who says this هم ناس لا يعرفون الواقع وليس لديهم أدنى معلومة عن حجم الصادرات الصادرات من روسيا التي تبلغ 240 مليار متر مكعب، والإنتاج متاع روسيا يعني يتجاوز 600 مليار متر مكعب جزائري. فيما يعني نقارن هذا بالإنتاج الجزائري، الجزائر تنتج 130 مليار. يعني اصلا يعني الانتاج التام بتاع الجزائر لا يعادل حتى الصادرات فقط من روسيا الى اوروبا فقط. يعني الجزائر لاوروبا تبعث 40 مليار، يعني there is حاجه مستحيله انها في المدى القريب. في المدى البعيد when you go to unconventional things can change. اوكي، والنقطه اللي حكيت عليها انه الغاز خلافا عن النفط لا يمكن تخزينه، يعني وكل ما يتم انتاجه يجري بيعه، فهمني؟ لكن الاستثمار والبحث والاستكشاف كده نقول نيو ريزرفوارز وي نيد تو فايند نيو كونتراكتس. لازمنا يعني لما عندي انا نيو unconventional when I want to start first before I start I need to find some contracts. نعمل contracts مع الدول how much you need because as soon as I start producing I need to sell. I cannot store it، ما نقدرش نخبيه. That should be it. يعني as final discussion, the last point that I want to mention is Algeria has a lot of potential, especially if they will use this unconventional. They need to, or all of us we need, I know, but الناس اللي في دائرة القرار لازم يدرسوا الموضوع ولازم يدرسوه بوطنية they find the people and اللي لازم يكونوهم باش ينجموا هم يقودوا هذه الثورة بتاع الانكونفنشنال. للاسف هنا في مثلا في نورث داكوتا وفي امريكا، في نورث داكوتا عندنا يعني تقريبا 20 طالب جزائري كلهم مختصين في الانكونفنشنال، كلهم يشتغلوا على مواضيع خاصه بالانكونفنشنال. هل انه الدوله الجزائريه او السوناتراك او الناس المعنيه بالاويل اند غاز في الجزائر they know that these people are here? I'm not sure and I don't think so. These people they can lead this revolution of unconventional. يعني لازم توجه الناس ولازم يعني كل الطاقات باش تكون التكنولوجيا، تكتسب التكنولوجيا، ثم لما نكتسب هذه التكنولوجيا we can go and start in the field and start exploring and producing from unconventional. That's it. Thank you very much all. Sorry if I took too much time and يعطيك الصحة. Thank you محمد. نعود نرجع لك الكلمة.
Barakallahu Fik, Doctor. It was a very interesting and informative presentation. You merely covered all the basics and fundamentals of from hydraulic fracturing to unconventionals and environmental impact and induced seismicity to how to manage those risks. Especially that for people that protest and manifest against the development of unconventionals, they don't know the technology that is ahead of us. And so to learn it or we seldom do that, unfortunately. So thank you very much for the presentation again. Sarah Alal joined us recently. She will cover the Q&A session. We will select some questions that will pop up on your screen and she will read your questions. So if you have any question, please select them and you can write them in the chat box. We are live in Facebook and YouTube and LinkedIn. We will select some questions. So Ms. Sarah will present you. So here's the first question.
Thank you so much, Qamruddin, for Dr. Foued.
Thank you. Happy to see you again, Sarah.
It was a pleasure seeing you again. I knew you as Foued, and now you are Dr. Foued.
I'm still always Foued.
My pleasure.
I think your connection is cutting, Sarah, a little bit. I'm not sure, is it only for me or?
Yeah, I think it's cutting. Yeah, we lost connection with Sarah. Maybe she will join shortly. Yeah, maybe Qamruddin, you can read it. You read the question, and maybe Sarah will text.
Okay, I will read the question as it is, like in French. Merci pour votre présentation. Ma première question concerne les types des réservoirs, coal bed methane. Vous les classez dans les types de ressources non conventionnelles? C'est ça la question. Est-ce que vous les classez dans les types de ressources non conventionnelles?
So, this is a good question. So, if we consider a coal bed methane as unconventional or not, it depends. So, you can consider it as unconventional in the large term of unconventional is what is different than usual. That is different than what we know. If you are using vertical well to get some impermeable coil bed methane, a bed that is permeable, and you just have vertical well, that cannot be considered technically as unconventional. But if it is a tight formation, then it can be considered as unconventional. So that's why it's a little bit technically it's not. So you can consider it unconventional and not. Depends.
Okay. So next question is from Ahmed Boras. Thank you for the presentation. How much is the average cost of horizontal drilling?
Okay, so the average cost, it depends if it is onshore or offshore, but the cost of a well, it can vary from $1 million to 10 million. It depends. And that's why this is a very important point. So thank you for this question, because this reminds me about bad thing that is happening in my country, in Tunisia. So we have a well, people who knows, I think Azrabal field. I don't want to name any company or anything. We have a well that we call Guinness World Record well. And can you imagine how much does it cost? It was a vertical well for a gas condensate reservoir. It cost near $300 million. And after they drilled it, they plug it and it's not producing today. And you can see the amount of corruption that we have to say that, because if we want to start this era of unconventional, we need to take off. Because if you remember my comment that I highlighted in red for their report of EA, they said thanks to the US, the state and federal regulation that made this successful. So back to that question, the cost can go from 1 to 10 million, and it can sometimes touch more than 10 millions, but that's the range of prices. It depends on uh, what logs are you doing? Are you doing some coring? Are you taking some cores from the well? Are you doing some imagery logs? Are you doing what types of logs? So that can define the range, the operation that you will do on the well will cost. But it's the range of 10 million we are talking about.
Okay, so the next question is also from Ahmed Boraz. What is the latest state of art on earthquake, frac, and seismic relationship? Is the correlation between microseismicity and natural occurring earthquake related to the local geology?
What is the latest state of art of earthquake fracking seismic relationship? So this is a hot topic that's happening here in the US. As I said, in Texas, they had big problem. Now the DOE is funding a lot of projects. So Department of Energy in the US is funding a lot of projects to study it well, because we are observing this happening, and we don't know the main sources, because it's not only fracking that is causing the earthquakes. It's the injection of water, the stored water, because the hydrofracturing water, when you are done from it, you are injecting it somewhere downhole. You find an old reservoir or a reservoir formation or a cave downhole, and you inject that water. And that water that you are injecting is causing mostly causing the earthquakes. So that's current study that people are working on today to try to understand that phenomena, because till today they don't know, because it's recently that they realized that happening. So when they saw year after year the earthquakes are increasing and increasing and increasing. The more hydric fracturing, the more stored water, the more you have earthquakes. But for the technical part, that's not something I'm working on, but it's a hot research topic that is happening today that a lot of people are interested in, and the government here is interested also in this topic.
Okay, thank you. So the next question is from Abdelkader first. He said that, Sana, do we have an idea about the maximum length of the induced fracture so that we can do proper risk assessment whether the hydraulic fraction fluid will reach the aquifer or no?
Okay, so let me go back to this slide here. So in this slide here, so we have something we call maximum width. And once you define the maximum width, a fracture has length, a height, and width. Okay, it's very important. So we control these three parameters: the width, the length, and the height. And these three parameters, when they are related to each other, so there are some properties also that they come into consideration, which are, oh, let me start writing. So let me. So we have something we call it pore pressure. Okay, if you are from the field, maybe you know what is pore pressure. So it's the fluid that is inside the formation, and we have the in situ stresses, or what we say, or how to say that in Arabic, the stresses.
Maybe sigma, no?
الضغط المكمني. So these stresses that are applied to the formation from these sides, they control how long, how wide, and how high is it. So we can control it. But now when you are talking about, if this fracture, let's say this fracture here, and this is the aquifer at this level, if this fracture can touch this aquifer, this is very unlikely to happen. Because as I said, this distance here, you are talking about more than 3K or 2 kilometers. So it's very unlikely this fracture to have to arrive here. So with equations, yes, I can predict this height of fracture or this length of fracture, but let's say, okay, you tell me maybe there have been a fault. Okay, so this fracture connected to a fault in phi. Well, you fractured, it touched the fault, and that fault propagated, and it reached this aquifer. This can happen, yes. But how we can detect that microseismicity can be an option. So when you are doing the hydraulic fracturing, you have another well here with sensors, and as soon as when this is propagating, you are sending signal here. I am treating it with computer, and I am reading the signal, and I can tell where is my fracture at that time. But as I said, it's very unlikely this fracture to reach the aquifer. It cannot happen. Okay, it can happen, but at 0.001%. The most problem that we have is along the wellbore that the contact will happen. Okay.
Thank you, sir. So there's another question from Sabri Salim. So my second question, what is the best definition to give for conventional and unconventional resources? I also think that there is not just the way of exploitation of these resources, but also the methods of exploration. That is the workflow of petrophysical evaluation or and estimation of the quantities of hydrocarbons. Merci pour la présentation.
Okay. So this is a very important thing. So when we talk about unconventional resources, so now the first thing, the most important thing is what you use after unconventional. Unconventional resources, when you say unconventional resources are the resources that are unconventional. Tight reservoirs, tight oil, tight reservoirs, and shale plays. These are unconventional resources. When you say unconventional in general, unconventional drilling, when you say unconventional drilling is horizontal drilling, hydraulic fracturing, completion that is not normal, that's not usual. So the first part of the question, he said, how do you define conventional and conventional? Unconventional is what is not conventional. That's the right answer, I think. So what is not conventional is unconventional. What is we were used to do it before the 90s is the conventional. After that, the new technologies are unconventional. Now, for the interpretation techniques, I didn't see anyone classify interpretation techniques as unconventional techniques. So this is something that I never heard of. The techniques are the same. They can change a little bit when you are dealing with tight formations, with shale, but there is no conventional interpretation and unconventional interpretation. There is an interpretation of conventional resources and interpretation of non-conventional. So the interpretation is interpretation. So we don't classify conventional and non-conventional based on the interpretation. No, based on the source, the type of drilling, the type of formation.
Thank you very much, Foued. I think since we are running out of time, I'm just going to pick one last question from the audience. We had so many questions, the debate can be carried on for hours, so we pick up the last questions. Can you read it forward, Kamaruddin, please?
Yeah, of course. So the question from Mohammed Yaqub. Thank you for your clear and rich presentation, Dr. Foued. Could water be replaced by other fluid, for example, using CO2 to frack or our reservoirs and store it there, similar to EOR using CO2?
Yeah, so this reminds me of a paper that recently was published, and I'm still in the process of reading that paper. So they tried to do something like that by fracking with CO2. And the only thing, the problem, fracking with the gas is not the best thing to do. So the gas, if you need CO2, you need it supercritical, and it does not have the properties to frack. Because to frack, we said you need the viscosity, that high viscosity, high pressure. So it's very unlikely that with only CO2 you can hydraulic fracture formation. If you can bring back the question, there is part that I want to check again. Yes, there is now another thing that I said I want to talk about, which is, and I said there is a student here, he's working on that. Quickly, I will show it here. So we have something we call fishbone drilling. So now that oops, anyway, yeah, this one is good here. So instead of doing hydraulic fracturing, so we come and drill some sections like this with the small bits. So instead of making fractures, I will drill these fractures. So I won't use fluid. I won't use anything that is bad for the environment. I will just use a small drill bit inside this section and go and drill this way. So it will be drilled type of channels. So we are working on replacing the hydraulic fracturing by what we call fish bone. You know, fish like a fish, you know, fish bone. So it's like, so this is the naming where it came from. So we create some bones to the wellbore. So this is a technique that can replace. And we have another Algerian student too. He's working on shockwave fracking. So fracking the formation with only waves. So you will send some sound wave or shock wave and create the fractures. So that's one thing. The other thing is also people that are working on laser the fracturing. So they are using laser to make the fractures instead of using water. Yeah, so that should be
Okay,
it.
thank you very much, Dr. Foued Badrouchi, for your time and for your very insightful presentation. I believe you covered outstanding spectrum of the fracking here, from the very basics to the advanced research, recent research on that topic. So thank you very much for your dedication and for preparation. I know that, it's a very busy season now at the university now. So just the fact accepting, for sharing with us this presentation is a really something that we really appreciate. So, Barakallahu Fik, thank you very much, Dr. Foued Badrouchi.
That's my pleasure. You're the most welcome. Thank you very much for this opportunity. So this
Thank
pleasure
you. I
for
also
me for
thanks.
coming here. And
I also would like to thank all the audience for their very interesting question today, and also maybe any final words, Qamruddin, before we close.
Yeah, thank you very much. Well, I had some questions, but it's a little bit of discussion. Of course, it's in the when we drill in the shale formation, like the clay content is very high, TOC and organic. We had some viscous stress relaxation. When we have the stress relaxation, like the minimum horizontal stress is approximately equal to the overburden stress. We don't know if the direction of the hydraulic fracture will be vertical or horizontal. So will that make an impact on the fracture growth or propagation?
Yes, definitely that will make an impact. So, what he's talking about for people who are not from the field, so we call إجهاد الموضعي, the in situ stresses. Knowing the in situ stresses is very important to predict the behavior of the fracture. So if you don't know it, that will be something hard. And I'm not sure when you say the horizontal stresses, they will be similar to the
like the differences between the three principal stresses will be equal, like isotropic stress state.
So when you have very close, so then really you cannot predict the behavior, but you can still have some ideas because you know the difference. That's why the importance of numerical simulation here. The use of numerical simulations comes to the stage. So you need to try to do some couple of simulations, try to understand, because yes, the stresses they are the similar, but you need to know the isotropy of the medium, the other geomechanical properties like Young modulus, like toughness, like everything of the fracture, how it's gonna propagate, because it doesn't only depend on the stresses, it depends on other properties. But simulation can be a way to predict on how it can happen. But if you have, as you said, very close stresses, yes, sometimes you don't know in what direction, in what how it will be open, axial, lateral fracture, or anything.
All right, thank you very much. And
Thank you for
with
your
that said, we
response.
would like to close this webinar, and looking forward, please keep in touch with the INAS International Network of Algerian Scientists webpage. We will keep you updated about next month events. Thank you very much, and have a good day. Keep safe.
Thank you, sir.